Okay, let's talk about something you interact with every single day. It's probably right next to you or maybe even holding you up right now. Furniture.
Mm-hmm. Definitely something we take for granted.
We really do. We don't often stop to think about it, but every chair, every table, every sofa has this hidden, complex journey.
Absolutely. It starts as raw materials, maybe wood from a forest far away, or plastic from a chemical plant.
Right, and it travels through these intricate supply chains, gets manufactured, arrives in our homes, and eventually, well, what happens then? That's often the murky part.
Exactly. And that journey, it often leaves a significant environmental footprint.
Yeah.
Resource extraction, manufacturing waste, and the huge amount of furniture that ends up in landfills when we're done with it, it all adds up.
And as you've probably experienced yourself, there's a real lack of transparency.
Oh, definitely.
We rarely know the full story, where the materials truly came from, the exact chemical composition of that finish, or, what the most sustainable option is when the piece reaches the end of its useful life.
And people are noticing. Consumers and regulators are increasingly, and rightly, demanding more accountability and sustainability from the industry.
So our source material for this deep dive explores how advanced digital technologies could offer a revolutionary path forward. We're talking about concepts like material ontology and AI-powered digital twins.
Pretty cutting-edge stuff for furniture.
It sounds like it. So our mission in this deep dive is to unpack these ideas based on the sources you've shared, understand how they could enable, well, radical transparency and deep life cycle intelligence, and fundamentally foster more sustainable consumption. What is most important in these sources? Let's find out.
And the foundation for unlocking this kind of transparency and intelligence, as the source material makes clear, really begins with understanding material ontology.
Okay, let's unpack this. The word ontology sounds pretty technical. What does it mean in this context for materials and manufacturing?
Yeah, it does sound a bit academic, doesn't it?
Yeah.
But think of an ontology, like a super smart standardized dictionary, or maybe a highly detailed library catalog, specifically for materials science.
Okay.
It's not just a list of terms, it's a structured framework. It defines what things are like oak wood or polyester fabric, how they relate to each other. Oak comes from an oak tree, is a type of wood, which is a material, and what properties they have. Density, color, tensile strength, stuff like that.
Ah, I see.
This creates a formal, shared representation of knowledge about materials that computational systems can actually understand and, importantly, reason with.
So it gives computers a common language to understand materials, like a Rosetta Stone for materials data.
Precisely. That's a good way to put it. The sources explain these ontologies are often built using specific digital languages designed for this kind of structured knowledge, like OWL, the Web Ontology Language. Sometimes they build on foundational frameworks like BFO.
Okay, the names aren't the key thing here, I guess.
Not really. The specific names aren't as important as what they enable, and that's the ability to represent materials information in a very flexible, detailed, and structured way.
And the core function of having this standardized language, what does it do?
Its primary job is to map concepts across what are usually very diverse, scattered sources of materials data. Just think about a single furniture piece. You might have data from a wood supplier, a textile manufacturer, a finish provider.
All in different formats, probably.
Exactly. Different formats, maybe different languages even. A material ontology allows you to integrate, exchange, and reuse that data intelligently. It's fundamentally about breaking down those data silos
Right.
and allowing different systems across a company or even across a whole supply chain to talk about materials using the same vocabulary and understanding.
What are the real-world benefits of this in manufacturing? Why go to the trouble of creating this complex dictionary? It sounds like a lot of work.
It is work up front, definitely. But the benefits are compelling, leading to significant efficiencies and capabilities that were previously difficult or, frankly, impossible.
Okay.
By providing this common semantic basis, it dramatically improves data quality and traceability throughout the production process. That's huge.
Traceability, yeah.
It harmonizes different software systems and streamlines the integration of data, which the source nodes can significantly reduce the time and money needed for system development and integration.
That makes sense. You're not constantly building custom translators between different databases, right?
Exactly. You avoid all that custom work. This common language enables powerful applications. It supports intelligent search across vast material databases
Ah.
and allows the development of semantic web services that can automate the visibility of crucial data for decision-making.
So getting the right info to the right place faster?
Right. In complex global manufacturing networks, a material ontology becomes the reliable reference point for achieving cross-domain interoperability. This unification of material information isn't just about efficiency either. It spills over into fostering innovation, enabling greener practices by making material impacts visible.
Which is key for sustainability.
Totally. And enhancing supply chain resilience because you have a unified, trustworthy view of your materials. So the key insight here is that material ontology provides the essential digital backbone, a universal language needed to connect material information across the entire life cycle. It unlocks efficiency and traceability that was previously just buried in disconnected systems.
Okay, so we've got the standardized language for materials, the ontology. How do we take that and apply it to an actual piece of furniture, giving it a dynamic digital identity? This is where the concept of the digital twin comes in, right?
Yes, exactly. And specifically, AI-powered digital twins.
Mm-hmm.
A digital twin basically is a virtual replica, a digital representation mirroring a physical asset, process, or system.
Oh, a virtual copy.
But adding AI, artificial intelligence, transforms it from just a static copy into something dynamic and, well, intelligent. AI algorithms can analyze the data associated with the twin, enabling predictions, informed decisions, and even automated responses.
And applied to furniture. How does that work?
Well, the source material discusses creating AI-powered digital twins, not necessarily for the entire piece of furniture as a single block, but for individual furniture components.
Component by component. So like a digital twin for this chair leg, another for the seat cushion. That sounds like a lot of detail to track.
It is, absolutely. But that granularity is where the power lies. These digital twins are fed data from sources we'll explore, things like material passports and potentially even usage sensors embedded right in the furniture itself.
Okay, sensors in my sofa. Interesting.
Yeah. And this combination unlocks what the source calls life cycle intelligence.
Life cycle intelligence for a chair leg. What does that look like in practice? How intelligent can a chair leg be?
Well, it means the digital twin, powered by AI analyzing the incoming data, can accurately predict the remaining lifespan of that specific leg.
Wow.
It can identify potential weak spots or failure points before they actually break. It can determine the optimal time for maintenance or repair interventions. Maybe it tells you that a particular joint is showing early signs of stress based on usage patterns and the material properties defined in the ontology.
So the digital twin isn't just a picture, it's a predictive model telling you the future state of that component. It's like a crystal ball for furniture parts.
Precisely. Maybe slightly more scientific than a crystal ball.
Mm.
But the synergy between AI and digital twins moves beyond static representations to create dynamic, intelligent systems that can proactively anticipate and adapt throughout the furniture's life cycle.
Right.
The AI isn't just processing data, it's using it to generate actionable insights. And critically, the data from something called a material passport is absolutely essential for giving these twins the information they need to be intelligent.
Okay, this brings us to that next concept, which sounds absolutely crucial for tracking all this component level detail. The living material passport. What's that about?
Yes, this is envisioned as a dynamic, comprehensive digital entity. Think of it like a unique digital birth certificate, an ongoing life story for each furniture component.
Each component, like that specific piece of wood, that bolt, that piece of foam. Seriously.
That's the ambition, yes. This passport is a repository designed to store vital information. Its origin, where the wood was harvested, where the plastic was molded,
Okay.
details about its production and assembly, its precise chemical content, its embodied carbon footprint, so the emissions associated with its creation,
Wow.
its usage history, how much stress it's been under, perhaps any maintenance or repair records, and crucially, its potential for disassembly and future reuse or recycling.
Wow, that's an incredible amount of detail. How do you ensure all that data is trustworthy and can't be faked or tampered with across such a complex supply chain? That sounds like a major challenge.
It is. And that's where blockchain technology becomes valuable. The source material suggests integrating blockchain to provide a layer of security and trust.
Ah, blockchain. Okay.
Its inherent immutability ensures that once data is recorded in the passport, it's incredibly difficult, effectively impossible to alter it without being detected.
Right, so it's verifiable.
Exactly.
Yeah.
It provides a trustworthy, verifiable record that everyone can rely on. Its transparency features also allow authorized stakeholders across the supply chain to access and review the information, which fosters accountability. So, immutability plus transparency builds trust, which is essential for data that will live and grow with the product.
And AI's role in this passport, you mentioned it's living.
Right, AI helps make it living and intelligent. It can dynamically update the information throughout the life cycle, pulling in data from those sensors we talked about, maintenance logs, maybe even user input, and other sources.
So it's constantly evolving.
Yes. And doesn't just store data. AI can analyze it to provide intelligent insights, like predicting potential issues with that specific component, or suggesting optimal end-of-life scenarios based on its unique history and composition.
So it's living because the data isn't static. It's constantly being captured and updated throughout the furniture's entire lifespan.
Exactly. This continuous data flow from manufacturing through to usage and disposal requires robust data infrastructure and seamless integration of various sensor technologies. And, as the source highlights, blockchain provides that critical assurance of data integrity and verifiable provenance, ensuring that the information guiding decisions about the product is reliable.
Okay, so we have the language, the ontology. We have the intelligent virtual copy, the digital twin for components. And we have the dynamic, trustworthy data record, the living passport. How does AI actually use all this information once the furniture is in your home to do useful things?
Great question. The source material highlights two really powerful applications here: predictive maintenance and smart end-of-life strategies.
Okay, predictive maintenance first. How does the AI know when my chair leg might get wobbly before it actually does? That sounds almost magical.
It's not magic, it's data. AI algorithms analyze the rich data sets available through the material passports and any usage sensors. They look at the specific material properties of the component.
From the ontology, right?
Exactly. They assess its degradation rates based on its history and environment, compare to historical failure patterns of similar components, and process real-time data like stress levels, temperature, or humidity where the furniture is located, if sensors are present.
So it's crunching material science data, historical data, and current environmental data. A lot going on there.
Yes. By analyzing these diverse points, AI can generate surprisingly accurate predictions of a component's remaining useful life and identify subtle signs of impending failure points that you might not notice until it's too late.
And this predictive capability allows for what?
For optimizing maintenance and repair schedules.
Instead of waiting for something to break or just doing blanket maintenance every 2 years, whether it needs it or not.
It's exactly right. It's a shift from reactive repair or fixed calendar-based maintenance to proactive scheduling based on AI-driven predictions tailored to that specific piece and its actual usage.
And the benefits.
Well, it minimizes inconvenient downtime, reduces unnecessary costs by fixing things before they cause bigger problems, and significantly extends the functional lifespan of the furniture, keeping things in use longer.
That's a big plus for sustainability.
Huge. But the source emphasizes, and this is critical, that the success of this totally relies on the quality and comprehensiveness of the data captured. If the passport or sensor data isn't good, the predictions won't be either.
That makes sense. Garbage in, garbage out, even for sophisticated AI.
Precisely.
Okay, what about the end of the furniture's life? How does AI make that smarter? We talked about landfill being a big problem.
Yeah, AI plays a crucial role here too, guiding smarter, more sustainable pathways when the furniture is no longer needed or wanted. By analyzing the detailed information in the material passports, remembering this is component by component, AI can suggest the most environmentally and economically appropriate end-of-life options for each part.
Like knowing exactly what each piece is made of, including the glues and finishes and everything.
Exactly that level of detail. AI can assess the feasibility of dismantling the piece to directly reuse parts that are still in good condition, maybe for repair or remanufacturing other items.
Okay.
It can evaluate the potential for remanufacturing specific components. For parts that can't be reused, AI can guide optimized recycling pathways, detailing exactly which specific materials can be recycled and how, taking into account their composition and any treatments they've received.
So it knows if that plastic bit is recyclable number 5 or number 2.
Potentially, yes. It can even assess potential residual value based on the component's condition, composition, and current market demand for recycled materials or used parts.
This sounds like it could be a massive leap towards a truly circular economy for furniture, making sure materials are kept in use for as long as possible.
It absolutely is. It maximizes reuse and recycling opportunities, drastically reducing the amount of furniture waste and lessening our reliance on extracting new virgin resources. But there's a key requirement for this, as the source notes.
Which is?
The AI needs a deep, granular understanding of how the furniture was constructed and the specific properties and composition of each constituent material.
Which loops right back to the fundamental need for that detailed material ontology we started with.
Exactly. It's all connected. The ontology provides the knowledge base for the AI to make these smart end-of-life decisions.
Okay, so we have these powerful tools generating and analyzing all this information about furniture. How does this translate into putting power into your hands, the person who owns and uses the furniture? How does the consumer benefit directly?
Right. That's key. The vision is that AI-enabled interfaces can give you, the consumer, direct access to your furniture's living passport.
Like scanning a QR code on my sofa leg and seeing its whole history on my phone.
Potentially. Something like that. Through user-friendly applications, you could explore the complete story of your furniture.
What kind of story?
You could trace its origins, understand the production process, see its embodied carbon footprint visualized, learn about its usage history maybe, and know its potential for future reuse or recycling when you're ready to part with it.
That would be fascinating. And maybe a little overwhelming with detail, perhaps?
Possibly. And that's where augmented reality, AR, comes in, according to the source. AR applications could enhance the interaction by overlaying this digital information directly onto the physical furniture you're looking at.
Oh, interesting. Like what?
You could maybe visualize the carbon footprint sort of emanating from the piece, or see step-by-step instructions for how to properly disassemble it for repair or recycling, layered right onto the object itself through your phone screen.
Okay, that makes complex info much more accessible and engaging.
That's the idea.
So the ultimate goal for the consumer is transparency and easy access to the story of their furniture, making it less of a black box.
Exactly. The force emphasizes that providing this level of transparency and interactive information can encourage more sustainable consumption choices. By fostering a deeper understanding of the product's life cycle and its environmental and social impact, it cultivates a stronger sense of ownership and responsibility.
Right.
You might be more inclined to maintain a piece, repair it, or seek out the proper recycling pathway if you understand its full story and future potential. It makes the information accessible and actionable, not just abstract data locked away somewhere.
Okay, this vision of intelligent, transparent furniture sounds incredibly promising and aligns perfectly with the push for sustainability. But let's get real for a second. What's the current reality? What standards exist already? And what are the major hurdles to actually getting all this implemented across the massive furniture industry?
Yeah, it's a big vision, and there are definitely hurdles. The good news is the industry isn't starting from a completely blank slate. There are existing standards that provide some foundation.
Like what?
Things like ANSI standards for furniture sustainability and performance, ISO standards for materials and testing, and regulations covering things like chemical content, such as formaldehyde limits.
Okay, so some basics are covered.
And, as the source points out, relevant ontologies exist in related fields. You have ontologies for art and antique furniture, describing styles and provenance, and ontologies in areas like product lifecycle management, PLM, or construction materials, like BMO, DICBM, and BuildMat.
So there's some groundwork there to build upon, maybe.
Yes, there is. However, the source notes limitations. Existing standards often lack the granular detail needed for a truly comprehensive life cycle approach, the kind that tracks specific components and materials from cradle to grave.
Right, they're maybe too high level.
Often, yes. And while other ontologies exist, they need significant adaptation to fit the unique materials, assembly methods, and complex supply chains of the furniture industry specifically. You can't just copy-paste an ontology from construction.
Makes sense. So what are the main challenges to actually making this whole system, the ontologies, the twins, the passports, the AI, work in practice?
Well, there are significant hurdles to widespread adoption. For ontologies generally, challenges include a lack of universally standardized design methodologies. Different groups might build them differently, making them hard to combine.
Okay.
Interoperability is a big issue because existing systems were often developed in isolation with differing perspectives on how to model data. Capturing and standardizing all the complex manufacturing knowledge needed is difficult.
I can imagine.
Ontologies need to be flexible enough for dynamic production environments, but static models are inherently hard to update quickly. Achieving seamless semantic interoperability between different software systems, from design to manufacturing to logistics, is still a major technical challenge.
So getting different systems to truly understand each other.
Exactly. And building a truly comprehensive ontology for something as complex as furniture, covering that vast material diversity and global supply chains, is inherently intricate. Plus, you sometimes encounter resistance from practitioners unfamiliar with these new approaches. Change can be hard.
Sure. That's just the ontology side. What about the furniture industry's specific complexities?
Right. The furniture industry has its own unique set of challenges that complicate data standardization and tracking. First, the vast diversity of materials used: wood, textiles, metals, plastics, glass, composites,
Yeah, it's huge mix.
each with different properties, manufacturing processes, and end-of-life requirements.
Hmm.
And supply chains are incredibly complex, often involving many tiers of suppliers scattered across the globe. Gathering, standardizing, and verifying data across all that is particularly difficult.
Right, tracking that wood all the way back to the forest.
Can be very challenging. And then integrating the AI and digital twins. What's hard about that?
Yeah, what are the obstacles there?
Implementing AI-powered digital twins also brings significant challenges. Integrating reliable, real-time data from multiple sources. Those sensors, the passports, manufacturing systems requires robust and scalable infrastructure.
Data plumbing.
And a lot of complex data plumbing, yes. Security and privacy are paramount.
Yeah,
This is sensitive data about production and potentially even usage patterns in someone's home.
good point.
And developing accurate and reliable AI algorithms specifically tailored for furniture applications like predictive maintenance, predicting wood fatigue versus fabric wear, or end-of-life optimization. Figuring out the best way to recycle a composite material requires specialized expertise and significant computational resources. It's not trivial.
And one crucial challenge the source highlights is figuring out the right level of detail for the material ontology itself, its granularity. You mentioned that earlier with the components.
Yes, that's a critical balancing act. It really is.
Yeah.
The ontology needs to be modular and adaptable. You need to capture enough detail to enable the intelligence like predicting failure or guiding recycling.
Hmm.
But not so much detail that the system becomes overly complex, slow, or difficult to maintain and use. And different stages of the product lifecycle actually require different levels of granularity.
Can you give an example of what that looks like, how the detail level changes?
Sure. The source gives some helpful examples. For initial material sourcing or maybe a high-level product design phase, you might only need a coarse or medium granularity knowing it's oak wood, steel frame, or cotton fabric. Pretty basic stuff.
Okay.
But for the manufacturing process itself, you need fine granularity, the specific batch number of the adhesive used, the chemical treatments applied to the wood, the specific polymer blend of the plastic, maybe even supplier-specific IDs. Much more detail.
Right, for quality control and process tracking.
Exactly. And critically, for end-of-life sorting and recycling, you need fine detail. Again, identifying the presence of hazardous substances, knowing the specific polymer types with their recycling codes, understanding how different materials are joined together.
So you can actually separate and process them correctly.
Precisely. So it's about having the right level of detail available when and where you need it throughout the product's entire journey.
It sounds like getting that granularity right is key to making the whole thing work without becoming unmanageable.
Absolutely. The success of integrating these ontologies in AI depends heavily on effectively gathering, managing, and disseminating data at the appropriate level of detail across the entire life cycle from multiple diverse sources. It's a significant data management challenge on top of all the technical and standardization hurdles.
So considering all these challenges, technical data adoption hurdles, how do we actually make this complex vision a reality? What are the recommendations from the source material for moving forward?
Well, the source outlines several key recommendations, and it really emphasizes that this requires a collaborative effort across the entire industry. It can't be done in silos.
Collaboration seems key.
Definitely. First, encourage the development of standardized, furniture-specific ontologies. This means building on existing work, but tailoring it precisely to the unique needs of furniture materials, processes, and supply chains.
So get everyone using the same detailed language specifically for furniture.
Right. Second, promote robust collaboration among all key stakeholders. Furniture manufacturers, material suppliers, technology providers, the folks making the AI, blockchain, sensors, and research institutions.
Bringing everyone to the table.
Yes, this shared effort is crucial for developing, testing, and implementing these complex systems effectively. Third, invest specifically in AI R&D tailored for furniture, developing those predictive maintenance algorithms, end-of-life guidance systems, and those user-friendly consumer interfaces we talked about.
Tailoring the intelligence to the specific needs of furniture.
Precisely. Fourth, actively explore and support the use of technologies like blockchain for providing that secure, transparent, and verifiable data infrastructure needed for the material passports, building that trust layer.
Makes sense.
Fifth, develop comprehensive training and education programs for the furniture industry workforce at all levels. People need to understand these technologies and know how to leverage their benefits.
Upskilling the workforce.
Exactly. And finally, explore government incentives and supportive policies that can help accelerate the adoption of these solutions across the sector. Things that can address those initial high costs and perceived risks for individual companies.
So it sounds like collaboration and supportive policies are really seen as essential to overcome the inertia and complexity to get this off the ground.
Absolutely. A collaborative approach ensures that the solutions developed actually meet the diverse needs of everyone involved in the furniture life cycle, from raw material suppliers all the way to consumers and recyclers. And supportive policies can provide the necessary push and maybe de-risk the investment needed to accelerate widespread adoption, enabling the industry to move towards a more sustainable future together.
So to wrap this up, the immense potential here seems incredibly clear despite the challenges.
It truly does. Integrating material ontologies and AI-powered digital twins has the potential to bring about radical transparency and provide deep lifecycle intelligence for the furniture industry. It really shifts how we interact with and understand the objects in our homes.
And the benefits aren't just theoretical or technological buzzwords.
Not at all. They lay the groundwork for a more circular economy by maximizing reuse and recycling. They can significantly reduce waste and reliance on virgin resources. They empower consumers like you with unprecedented information about the products you bring into your lives. And they foster greater accountability throughout the entire value chain.
So the path forward involves tackling those challenges head on.
Yes, by proactively addressing the technical, organizational, and data-related challenges, and by embracing these collaborative recommendations, the industry can move towards a significantly more sustainable, transparent, and resilient future. It's a powerful convergence of material science, AI, and semantic web technologies, essentially bringing intelligence to previously inanimate objects.
It really changes how we think about something as commonplace as a chair or a table. It gives it a story, a history, and a defined future path.
It does.
And that brings us back to you, the listener. If every piece of furniture you owned had a detailed living passport, you could easily access and understand, knowing its origins, its impact, its potential. How would that change what you choose to buy, how you care for it while you own it, and what you decide is the right thing to do with it when you're finished?